problem, in this big problem, they're giving us some points, and eventually what they're going to have us do is go graph all these points, draw the figure, and tell what kind of figure it is based off slopes. And we're going to find that there's some slopes that are going to be perpendicular to each other as we work this problem out. And then also based on how long the sides are. Didn't we classify figures sometimes by if the opposite sides were like parallel or if the opposite sides were equal to each other? And we had things like squares where all the sides were equal, and then we had rhombuses or rhombi where all the sides were equal there. And then we had things like rectangles where opposite sides were equal. So that's the kind of thinking we're trying to do here. So if you look at 23, they give us this, the big instructions here say find the slopes of the lines through the following pairs of points. So first of all, if you look at 23, they're going to give us the point B, and you may, as you're going, you might just want to graph these things as you go and label them on that big piece of graph paper because eventually you're going to have to do it, even though he doesn't tell you that till the end, and then you're going back and you're doing it all. So if you wanted to, you could do that as you go. I'm not going to show that on here just because I don't have an easy piece of graph paper to pull up. Now, if I want to know the slope of that, remember the slope formula, if I label these points, x1, y1, that's my first point, so that's the x of the first point, the y of the first point. Here's my second point, so that's the x of the second point and the y of the second point. My slope formula is y2 minus y1 over x2 minus x1. Okay, so in 23 through 27, he's giving you, in each one of those problems, you're having to do the slope formula. So we're just going to do, a couple of these together. Well, what's y? If you think about it, you're subtracting on the top and you're subtracting on the bottom. Sometimes it helps to put that in there just in case you get negative numbers, just so you kind of already got that in there. So we're supposed to put y2 here. What's y2? It is 7, right? And then y1. What's y1? It is this 4. So on the top I have 7 minus 4 is 3. Okay. And then on the bottom of my slope I subtract my x's. That's kind of backwards. The points always give the x first and the y second, but the slope you subtract the y's on top. That's the rise part. And you subtract the x's on bottom. And most of the time if you mess this up, it's because people accidentally put the x's on top because they think that's what they're supposed to do. But remember, the formula says put the y's on top. Okay, so for x2, I'm supposed to put that here. I'll circle that in blue. Here it is, 10. And then you're subtracting x1, which is minus 1. And 10 minus minus 1 is the same thing as 10 plus 1, and that would be 11. So my answer for 23 is I have this slope, 3 over 11. Now the thing about it is you're going to calculate 4 more slopes, and you need to be on the lookout because some of them might be the same slope. If you end up with 2 lines that have the same slope, what do we know about those? They are parallel, okay? And if we have 2 lines that have opposite reciprocal slopes, let's say I found out that I have 3 over 11 here, and somewhere else I calculate one and it's negative 11 over 3, what do I know about those 2 slopes? They're perpendicular, okay? So these are kind of the things we're on the lookout for. It may not be that we're going to have a perpendicular one to 3 over 11, but we just kind of know to be on the lookout for things that might fit this pattern. Okay, so let's look 24. We'll do one more of these together. 24, they give us the point C, which they've already told us was 10, 7, because this is one big figure we're drawing. And now we get D, which is 3, negative 2. Okay, so I got to do the slope formula again. And again, I can relabel if I want to. I could say maybe this time this is my x1, y1, and this is x2, y2. And I need my formula for my slope. And remember, we subtract the y's on top, and we subtract the x's on bottom. This is something we did back in Algebra 1, maybe medium to early part of the year last year. Okay, so I always put my subtraction signs in just so I don't forget them. My y2 value here is negative 2, and then I'm supposed to put in, let me circle that with a different color. I'm supposed to put in y1, and it's over here, it's 7. What's negative 2 minus 7? Negative 9, right? I don't want to let the video roll too long here, waiting. And then x2, I'm supposed to subtract x2 minus x1. Well, x2 over here is 3, and then x1, do purple on it. Here's my x1 value, 10. What's 3 minus 10? Negative 7. And then a negative over a negative is a positive, so the slope here is 9 over 7. Again, we're going to be paying attention to these numbers because in a minute we're going to notice something about some of the slopes. And by the time you get through 27, you'll notice that you've got something that's perpendicular in here. And until you draw it on the figure, you're not quite sure what it is. So that's why you want to graph these points as you go and label them B, C. There's a A, B, C, and a D here. Okay, so we've got the point B is negative 1, 4, and C is 10, 7. And I know that I'm going to need my distance formula here because they say find the distances between the following pairs of points. Now the reason they're having me find the distance is we're going to draw a figure and we want to know how long the sides of the figure are. So we're going to be calculating that so that once we get it on our paper, we're already going to know how long it is, how long each side is. That's what they're having you do is calculate the length of each side. We already know that right above here they did AB and they found out that AB was the square root of 130. Let's kind of see what happens when we do BC here. Now the distance formula, if you didn't copy it down, here it is. It's you subtract your x's and you square them. So it's x2 minus x1 squared. And then you're going to subtract your y's, y2 minus y1 squared. And you get those numbers, you add them together, and then you square root that total. If you remember, the distance formula and the Pythagorean theorem were the same thing, so we could have counted this off on the paper. If we put it on a graph, we could have counted the sides off and made a right triangle, but I want us to go ahead and do this because there are times in Algebra 2 where you use this formula to come up with some equations, and so I want us to be able to do this too. So even though we could do it with the Pythagorean theorem, we're going to use the distance formula here. All right, so I can tell that I need to label my points again. I need some. I could say, well, this is point, I'll call B point 1 here. So this is my x1, my x of my first point. Here's my y of my first point. So I'm going to label it. And then over here on C, I'll say C is my second point. So let me label that x of my second point and y of my second point. Now, when I'm plugging this stuff in here, it often helps me to do this, to go ahead and put the subtraction signs and the squares, because you know what happens is people accidentally forget to put squares in, or they do something wonky with the pluses and the minuses, and they get them, then that messes them up. So this can be a way when you're having to plug stuff into a formula that you kind of get the basic outline there, and then you're just sticking the numbers in. So if we look, let's color code the numbers. I'm supposed to put x2 in that first parentheses, and x2 I labeled it, it was 10, wasn't it? So I stick it there. If you have told me that you're having trouble with the distance formula, you should be watching right now. Some of you, I don't see you watching, and you've told me you have trouble with this, so make sure you're watching. Then I'm supposed to subtract x1, and so where's x1? It's right here. I'm filling it in. It's negative 1. I'll go clean that up in a minute. Okay, I see that I got to plug in y2 and y1 over in that second parenthesis. So y2 right here, what is it? It is, over here I labeled it 7. So I'm plugging it in. And then we got y1. Let me do it in a different color. I'll just use the screen here. y1 is going to go right here, and y1 is, I labeled it, is 4. So I plug it in. This is stuff that y'all have done for a long time in 7th grade. Y'all were evaluating formulas, we were sticking stuff in all the time. This is what evaluating formulas looks like in geometry, and a lot of times even in Algebra 1 and 2. Okay, so we got to think about order of operations here, PEMDAS, right? So if I know, why did I do that? I don't know. PEMDAS. So I got to do the parentheses first. And let me go ahead and do this. I'm just going to go ahead and put the squares on stuff. In the first parentheses, what is 10 minus minus 1? What does that become? It becomes 10 plus 1, which is 11, okay? So, and then on the second parentheses, we're going to do it next because PEMDAS says do the parentheses first. What's 7 minus 4? 3, okay? So now it's looking like that. Already looking better, right? Just by using PEMDAS. Okay, PEMDAS says we do exponents next, and I got 2 exponents inside that, underneath that bar there. What's 11 squared? 121. Yep, 121. And then what is this 3 squared right here? 3 squared is? 9. Oh, when I add those together, 121 plus 9 is 130. Huh. What this tells me is that the length BC from B to C, that length is the square root of 30. What did they tell me earlier that AB was? Yeah, so what do we already know about these two sides? This side here, they told me, they did that as an example, it was the square root of 130, and now I know from B to C is the square root of 130. These two sides are going to be equal, aren't they? So I don't know if you've already graphed your points, but you could actually go ahead and put your lengths out beside them on your graph so that you can actually see, are those next to each other, or are they across from each other? Because that would make a difference, you know, on how this is going to turn out.